So today we're going to tackle a challenge that a ton of developers are facing right now, adding that powerful AI-driven semantic search into a database you already know and probably love, Postgres. Now, it sounds simple enough, but trust me, the devil is absolutely in the details. Okay, so let's just get right into it, because this is the first question everyone asks. A vector embedding. I mean, it's just an array of numbers, right? So why can't you just create a column and dump it in there? And the thing is, you can. The problem isn't about storing the vectors. The real challenge, the part that makes all the difference, is how you retrieve them efficiently. And that brings us to this fundamental conflict, this problem with precision. You see, your trusty old database thinks like a very strict accountant, but what AI really needs is more of an artist. What's so interesting here is the contrast. Your relational database is totally binary. It is built for exact matches. Find me the customer with ID 4269. It's either a perfect match or it's not. Simple. But with AI search, we're asking a completely different kind of question. We're saying, hey, find me documents that feel like this one, that talk about the same ideas, even if the words are totally different. We're not chasing precision anymore. We're chasing similarity and meaning. And this chart just illustrates so perfectly why performance is king. Most of the time, you're using these vectors for something called retrieval augmented generation, or RAG for short. And RAG systems are a classic read-heavy workload. I mean, look at that. You might write or index a document one time, but your users are going to be hammering it with thousands of questions. Your database has got to be an absolute workhorse for reads. So here's the crucial point. What happens if you don't have an efficient way to search? Well, if you've got, say, 10 million vectors, a single query forces the database to do 10 million separate math computations. It has to compare your question to every single row. The latency just shoots to the roof, your CPU is on fire, and your user, they've already left to go make a sandwich. This brute force thing, it just doesn't scale. This whole performance problem leads directly to a massive architectural headache that, well, we're calling the two-fridge fiasco. And this quote just nails the problem perfectly, doesn't it? When your data lives in two different places, even the simplest tasks become chaotic. You go to make a sandwich, you grab the cheese from one fridge, but hold on, where's the ketchup? Oh, right, it's in the other fridge. It just leads to duplication, a ton of confusion, and frankly, a huge mess. And this creates a very real, very painful technical problem we can call synchronization hell. Just imagine, you delete a user in your main Postgres database, but you forget to also delete their stuff from that separate vector database. You know what you get? Ghost results. Your app starts showing data that shouldn't even exist anymore, and that is a recipe for some really nasty bugs and a terrible user experience.
So what's the alternative to all this madness? Well, it's the all-in-one solution. It's putting your cheese and your ketchup together in the same fridge, using Postgres with the pgvector extension. This brings both power and, more importantly, sanity back into your architecture.
And the advantages here are just huge. With everything in one place, you can delete a record in a single reliable ACID transaction. Poof, no more ghost results. And here's the real game changer. You can write a single SQL query that combines a traditional filter, like, say, a date range, with a deep semantic vector search. And you do it all with the same familiar SQL tools you've been using for years. I mean, that is a massive, massive win for developer.
Okay, so you've decided to go with Postgres. Awesome choice. But before you take off, we need to go through a pre-flight checklist. These are the critical gotchas you've got to know about to avoid some serious turbulence when you hit production.
All right, let's break these four down because they're super important. First, you absolutely must create an index on your vector column. If you don't, you're right back in that brute force trap we talked about earlier. Second, and this is a big one, that index has to fit in RAM. If it spills to disk, your performance will fall off a cliff. It is literally the difference between a Bugatti and a tricycle. Third, you've got to remember that Postgres only stores the vectors. Your application is the embedding factory. Your code is responsible for calling the AI model and actually creating the vectors, and that adds another moving part. And finally, ongoing maintenance, running vacuum, yeah, that's not optional. It is totally non-negotiable if you want to keep things running smoothly. And here are two more quick gotchas, and these are tied directly to your AI model. The dimensions have to match perfectly. If your model spits out a 1536-dimension vector, your database column has to be defined as exactly that, or you're going to get errors. And also, you have to watch the model's token limit. If you try to embed text that's too long, the model just chops off the end. It ignores it, and you lose data without ever even knowing it happened. So, with all of that in mind, let's get to the final verdict. how does this whole Postgres plus pgvector solution really stack up in the real world? Let's take a realistic look at the setup, that all-important developer experience, and, of course, performance. This table really breaks it down nicely. The setup? It's deceptively easy to get a little demo running, but making it truly production-ready? That takes some real DevOps work. The developer experience, though, it's an absolute delight. I mean, being able to use standard SQL joins with vector data is a total game changer. And for performance, it's a beast on read-heavy workloads, but you do have to be careful with writes. Updating that index is an expensive operation, so you can't just be throwing millions of new vectors at it all at once. So I think the biggest takeaway here is this. Once you get past that simple proof of concept, this is not a fire and forget solution. It is fire and monitor. You have to pay attention to it. You've got to do regular maintenance and performance tuning. It's an incredibly powerful tool for sure, but it demands some operational maturity. Which brings us to our final verdict. It scales, but with an asterisk. Look, Postgres is a proven, battle-hardened database, and adding vector capabilities basically gives it superpowers. But that asterisk is there for a reason. You have to be willing to get your hands dirty with index management, memory tuning, and that ongoing maintenance. If you have that expertise, or maybe you need to keep your sensitive data in-house, then Postgres with pgvector isn't just the cheaper option, it's very often simply the right solution.